All right, here we go. So we're looking at 6.92. We've got a car coasting on a horizontal road. Ooh, right away I see horizontal, and I know what's not changing. The height. So what type of energy must not be changing? Potential energy, gravitational. So when I see horizontal, right away I'm thinking, oh, I don't have to worry about potential energy, gravitational. And then with this speed, ooh, it has inertia, it has speed. It must have what type of energy? Kinetic energy. Oh, I forgot to cast out, didn't I? So it must have kinetic. Okay. So passing over an unpaved sandy stretch, 25 meters long, car speed is decreased to this. Ooh, if its speed decreases, now I'm thinking, okay, it's kinetic energy change, right? Was the network done on the car positive, negative, or zero? Okay, let's think. Now I'm going to go into my why. Did the energy of the car increase or decrease? Did the energy of the car increase or decrease? Or decreased, right? Because it had. So I'm gonna, in my why, I want to make sure I show that I understand. You know, the kinetic energy is due to motion and inertia. And then I would also want in there for this first part, when the car slows, the kinetic energy decreases. Let's see what else they asked me about. And then, oh, okay. I need to show, they mentioned force in there, right? They mentioned force here, and I know, and I need to show that I understand that work is done when a force is applied in the direction of motion. And the network changes, oops, I forgot the word work there. Work changes the kinetic energy. So I need to show my reader I understand what kinetic energy is, that I understand that when it slows down, the kinetic energy decreases, that work is going to be done on it, and that work is what changes my kinetic energy. Those are the points I would need in my why. Any question on those before we jump to the how? Are we good? Excellent. All right. So I'll let you answer A, because hopefully from that why you can figure it out. So B, what's the magnitude of the net force on the car in the sandy section of road? I'm going to look at my equation sheet, which is right here, and I'm going to notice that net work equals the change in kinetic energy. And that's where I'm going to start with that work net equals the change in kinetic energy. I know that work, I also have the equation there, that work is force parallel delta D parallel. Let's see, did they ask me that? Yeah, average net force, okay. So I'm going to bring in these two together, force and D, and I know the two are parallel. Can I remember, is change in kinetic energy, is that kinetic energy initial minus final, or kinetic energy final minus initial? Final minus initial. So KE final minus KE initial. Oh, I need my equation for kinetic energy. Here, I should just write that up here. KE equals 1/2 mv squared. So what do they ask me to find? They ask me to find the force, right? So I'm going to just combine, put these together into one expression, right? I just brought the delta D on the other side. And then I have 1/2 V final squared minus 1/2 M the initial squared over delta D. Should we just throw in numbers or should we simplify it? Or can you guys take it from there? Throw in numbers at this point? Okay. So if you throw in your numbers, then you just know them. It's 1/2, whatever your mass is, 1,300 kilograms. The final velocity is, for me, is 14. I'm about to run out of room. Minus 1/2 1,300 kilograms. I think my initial speed was 19 meters per second. Is that going to give me a positive or a negative answer? Negative. Because V initial was higher than V final, which makes sense. And I go 25 meters. So I'm going to have a negative top to my fraction, a positive bottom. So that means my answer for F is going to be positive or negative. Negative. Should I put in the negative value or should I put in a positive value for my final answer? Well, let's see. What does it ask for? It asks for the magnitude. So positive, or we can think of it as sign neutral, right? And they also, look at the variable that they show you. What do those two lines on either side of it mean? Absolute value. So make sure you put in the positive value. All right? Good. That should do it for that one. Unless there are questions. All right, so we're doing number 10, which is 6.140, so 6,140. And so in this one, we may have to do our Y in a couple of stages, since I only see parts of it. Or is there only one part to this one? Yeah, I guess there's only part A, right? So the airplane, is the airplane gaining energy or losing energy compared to starting at rest at sea level as compared to being at a cruising altitude at a certain speed? Is it gaining energy? What type of energy is it gaining? Kinetic energy because now it's moving. What else? Potential energy because it's increased its height or increased where it is in gravity. So gravitational potential energy. So those are all the ideas that I would express in the Y. Is, things like the plane increases its energy. gains kinetic energy due to its motion and potential energy grav due to its height. See if there's anything else we need in there. Let's see. No, that's it. So we all agreed that it's the energy at the beginning. We'll call that 0 because it's sitting on at sea level, and it has it's not moving. The energy final, that's going to be a combination of its gravitational potential energy and its kinetic energy, right? Just like we said. Potential energy, gravitational plus kinetic energy. And so the change in energy, as all changes are, would be energy final minus energy initial. That's easy. What's energy initial? 0. So let's see. I need to remember the equation for potential energy gravitation. Let me grab let's look at the equation sheet. It's this one over here, right, on the right-hand side. And right above it's kinetic energy. That's convenient. So this is going to be mg. What's mg again? No. The mass times I, which is the weight. Sam, what's mg? We'll try it. What's mg? Someone said it. So wait, Sam, what's mg? Alex, what's mg? Okay, let's go hard. Colin, what's m? All right, we got it. Let's go way in the back. Richie, what's mg? Excellent. Nicolette, what's weight? You guys, you just outshone A-Block. You just did. You just did. Good job. Times the height. Huh? Yeah, it's on the video. Yeah. It's on their video too. Oh no. Huh? Them doing the same similar type thing. Yes, or added. It's up to you. Yeah. What's weight? Then you can. Do you guys want to simplify that first, or just throw in numbers? Okay, so throw in your numbers. And while you're doing that, I will throw in my numbers. Let's see. 1865. Is kilograms the good unit for mass? Yeah, okay. And then the G is going to be the gravitational field strength, so 9.81 newtons per kilogram. My height, what unit should my height be in? Meters. Oh, nice, they gave it to me in meters. 2,420 meters. Plus 1/2 Look on the back of your equation sheet. And meters per second. So, oh, good. So, and then just solve. What's your, if you just do all these units, what's your answer going to end up being in it? What units? What's our base unit for energy? Joules, right, good. So make sure you convert it before you put it in. All right, so number 7, 6.57. The power output of a 1.5 gram fly that walks straight up the window pane at 2.8 centimeters per second. Uh-oh, centimeters. Centimeters, one of my happy units? No, what should it be in? Meters, meters. Yeah. Let's see. Aiden, what's MG? Excellent, excellent. And then, uh-oh, I have other units. Oh, but I learned I can change the units, right? If I don't want to deal with milliwatts. So, power, is there going to be a force working against the fly as it goes straight up the window pane? They're going to have to work, gravity, its weight is going to be working against it, right? So I'd probably start my Y with that. What was it, 6.57 or something? So the fly's weight will work against it. Good. Up the pane. The window pane, what does it say? Window pane, yeah. Probably also be good to show in there that power is the rate work is done. How much power it has to use to maintain that. Yeah. Now, if we really think about where is that the energy it's using, where is it going into? The work that it's doing, what type of energy is it changing about the fly? Is it changing its kinetic energy? If it's maintaining a constant, if it's maintaining that speed, is it changing its kinetic energy? No. Is it changing its potential energy? Yeah, because it's changing its position against that force of gravity. But what I'm going to encourage you to use is the last definition of power, which is power is the force that's resisting motion times the motion, the velocity, the speed. So that's what I'm going to use on this side. Power is force times the speed. Right on our equation sheet. Do you see it? Remember, all of these are equal to each other. But rather than writing P 4 times, just string them all together. And so the force I said was its weight, which is mg, and then its speed, which is v. And now I know all these, right? I can substitute in. Its mass is, oh no, that's in grams. What unit should I have that in? Kilograms. So I'm going to put in 0.0015 kilograms, 9.81 newtons per kilogram, and then multiply that by, I've run out of room, my speed, which for me is 0.028 meters per second. I converted that from centimeters per second to meters per second. And now just plug it in. So make sure you watch your units on some of these, especially things like little flies. What units is this going to end up being in? If I'm taking kilograms and newtons per kilogram and meters per second, I'm going to get an answer in, or joules per second, which is also what's called a watt. Remember, the prefixes are on the back of your equation sheet, and there's that video up in Ed Puzzle if you need a refresher converting between methods.